Okay, I decided it was kind of misleading to call this tutorial a predictive text tutorial and not actually have the predictive text feature that you're familiar with when you're writing a message on your phone or something. So I'm going to continue and I'm going to add a fourth option, and let's call that type with predictive text. And make sure when they type 4 we call the function called type with predictive text, which doesn't exist yet, so let's create it. Define it, create another scanner, and we're going to create a string called total input, and this is just going to keep track of their entire text, everything that they've typed so far. And then we're going to give them some instructions that say start typing and press enter when you want the computer's help. Okay, and now we need a while loop to go on forever. We just want it to keep going while they keep typing and never end. So we say while true. So we're going to print out their total input every time so that it appears that they're typing directly after everything they've already typed, even when they press enter. And we're going to receive that input and append it directly onto total input. And then we're going to do something kind of tricky. We're going to take that total input string and we're going to split it by a space, meaning it's going to look at where all the spaces are and it's going to make a list of all the words separated by spaces. And let's save that in an array of strings called list words typed. Okay, and then we need to get the last two words of this list so that we know what words to offer as predictions. So let's save the last index of this list, looking at the length attribute of list words typed and subtracting 1 from that. And then we're going to say current words. If you remember in the previous function, current words is the key we use to look up the different words that could follow and are the predictions. So we're going to create that variable and set it to be whatever the second to last word is in the array, appended to a space, and whatever the very last word is in that array. Okay, and then we need to create an array list. We'll call it following words, and we'll just pass in that key and get the value. And now we need to create a list of suggested words. So we're going to take that list of all the possible words, and we're going to somehow figure out which ones are the most frequent, which ones occur the most often. And so let's just create a function called getMostCommonWords that takes an array list and then returns that list that we're looking for. And so we'll set that equal to whatever that function returns. And assuming that gives us back a few words we can suggest, let's iterate over all of the suggestions, leaving a space in between each one. And then after all that, we're going to print a new line for the next iteration. Okay, so now we have to write the getMostCommonWords function. So let's define that. And of course, it's going to return an array list of strings, and it's going to take an array list of strings. And let's just call that words for this function. And we're going to make use of a map again here. We're going to create a new map, and this one is going to be mapping strings to integers. We're going to use each word as a key, and then its value will be how many times that word occurs in this list. And let's call it word frequency, and let's just instantiate it to be a new hash map. Okay, now let's iterate over all of the words in this array list, and let's check if it already exists in our map. If it equals null, it means it doesn't, and we need to put that word in our map with the integer 1, because we just saw it for the first time in this list. But if it does already exist in the map, that goes in the else part, then we just need to get the current value, which is how many times we've already seen it in the list called words. And let's save that in a variable called freq, which is an abbreviation for frequency. And then we can just put that new value inside the map by passing in the original word as the key, and then a different value. It'll be freq plus 1. So that'll increment the number. It'll increase it by 1 because we just saw it another time while we're looping through. Okay, now we just need to run a max finding algorithm. And you might be wondering if there's an easier way to do this. Yes, there is. We could create a comparator, something that's a little bit more advanced than I want to do here, and we could easily sort this map by frequency, and then we wouldn't have to worry about sifting through and searching for a max and then removing that, and then searching for the next highest, and then removing that one, and then searching for the next highest. But like I said, I'm not going to do that here, so let's just do that. Let's search through, find the highest, and then remove it, then find the next highest, remove it, and each of those highests that we find, we're going to add to a list of most common words, which we will return at the end. So let's write a for loop, which goes over all of the entries in our map, and it looks like this. And let's get the key for each entry and the value for each entry. And let's just check if that value is greater than our current max. And if it is, then our max becomes that value, and most frequent word becomes that key. Then, of course, at the end of the for loop, we will have the most frequent word stored in the variable called most frequent word. So we need to add that to an array list, which I've already created up here, called most common words. And then we need to remove it from our map, which is called word frequency. That way, when we loop this, which we're going to do in a second, we won't see that word again because we already know that that's one of the most frequent ones. Now we need to get the next frequent one. So, like I said, we're going to make a loop around this. So let's just add a for loop around all of this part, and let's make it happen 3 times. So it grabs the 3 most common words if there are at least 3 possibilities, and it's going to use those as suggestions. And we've already returned it, so it should work now. So let's just run it. And let's read that training file, pnp.txt. And now let's choose option 4, which is type with predictive text. It looks like I need to fix a couple things. I have a typo in the word typing. How ironic. And then I don't want it to wrap to the next line yet here. I just want it to print and let me type on the same line as all the other input I've already given it. And now let's try it again. So start typing and press enter when you want the computer's help. So let's just start with, of course, the traditional it is. And it gives us a few suggestions here. We could say we could say not, we could say very. I'm going to type 2 more words here. I'm going to say a very. So now we have it is a very, and press enter. And it gives us more suggestions. I could say it is a very good, it is a very different, it is a very agreeable. Let's say good. It is a very good. And then suggestions, it gives me kind, sort, notion. So let's choose kind. So now it says it is a very good kind. And we only get one option for this one, apparently, and it's of. So let's try typing in of. So I say it is a very good kind of, and we get more suggestions. It is a very good kind of love. So there you have it. I know I've said this a few times already. This is the final complete version of this program, the complete version of this tutorial. But I think this is where I'm going to end it. I don't know that I'll add any more to this. Of course, if you have more questions, I'm happy to help you expand on some of these ideas. I'm happy to help you accomplish the same things in different ways if you're interested in that. Let me know. I'll be happy to help.